So with this question, you have x going to infinity, you plug in infinity, you plug in the number always to see what happens, and when you plug in, I mean, look, you have infinity squared minus 2 times infinity plus 5 over infinity plus 2. It is not a basic limit, so when it's not a basic limit, and by basic limits, remember, we have very simplistic number over x to a power, number, or x. So if it's not a basic limit, then what we need to do is we need to divide by the denominator power, specifically the highest denominator power. So here the highest denominator power is x to the first, because this 2 would just be a constant, which would have a power of 0. So first step is to divide, and we still have the x's, so we still have the limit notation. So it's x going to infinity, x squared is going to get divided by x, minus 2x divided by x, plus 5 over x over x plus 2 over x. And the whole point of dividing by this highest power in the denominator is that hopefully when we simplify, we will see that things are now looking like some of our basic limits. So if I simplify, I'm going to subtract the exponents. So x squared over x will just give us x, minus these x's cancel out, plus 5 over x over these x's cross to 1, cancel to 1, plus 2 over x. And now things are back into one of those three basic limits. So here we're using our basic limits, and specifically the limit that's going to be very important for us is that if we have a number over x, that is going to go to 0. If it's a power p or just x, it's going to go to 0 as x goes to infinity. So we can look at all of this mess that we have and say that when we have this x in the denominator, that is going to go to 0 because we'll have a big number in the denominator, and this 2 over x is going to go to 0. So if you look at what you're left over with, and I always kind of do this as two separate steps, if you look at what you're left over with, you have x minus 2 over 1, and the 1, of course, isn't going to have any impact on us, so it's just x minus 2. Now, we do have a basic limit for x, but really what you can think about is that if there's an x left there, if x is still there, then what we're going to do is we are going to plug in. And really what we're plugging in here is to figure out if it's plus infinity or if it's negative infinity. That's the decision that we're trying to make. So if I plug in infinity for my x, I'm going to have infinity minus 2. And this little negative 2 isn't going to amount to anything in comparison to infinity, so that tells us that the sign is a positive infinity. So our conclusion here is that this limit is equal to plus infinity. So if the x is still there, you need to plug in the infinity for x and see if it's a plus infinity or a negative infinity in terms of signs.